So, welcome again into this third lecture, and we're trying to do a foundation of mathematics. And our task was to take a theorem and backtrack it and see what are those statements or facts, or you can say axioms, that we need to presuppose to even state a theorem or to prove a theorem. And to illustrate this, we took an example of uh, a theorem from classical geometry, Euclidean geometry, and the theorem was that sum of interior angles of a triangle makes 180 degree. And we saw that to prove this theorem, our first our first move was to draw a parallel line with respect to the base of a triangle, right? But then we came up with a problem, because we found that given a line and a point, there is exactly one line passing through this point that will be parallel to this given line. And we saw that this fact that we assume, this fact already assumes another fact. And the fact was, and we backtracked it, and we found that the fact was, given a point, infinite number of lines can pass through it. But we ran into a problem for this fact, because we saw that given a point, maybe I should make you understand this through illustration here, through pictures maybe. So what we said that we wanted to prove that this given a triangle, this angle alpha, beta, gamma, the sum of angle alpha plus angle beta plus angle gamma makes 180 degree. And the first step was in proving that given a point A, B, C, the first step to prove was this, that here is a line given, there is AB, a line is given, and here is a point. So Euclid says, given a line which is AB, this line, I am just taking this line and putting it here. So given a line which is this, and given a point which is C, put it here, C, this C can be anywhere, but only restriction is that C cannot be on the line AB. Otherwise you can put here, 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 even here, even here, even infinite distances from this point AB. So Euclid says, given a line AB and a point C not on the line AB, then there is only one line that will pass through this point C, and that will also be parallel to AB. See, there is two conditions here. First, line will pass through C. It means that is assumption. A line can pass through a point. A line can pass through a point. That is assumption. Now he says, given a line and a point, there is exactly one line that is going to pass through C, and that will be parallel to AB. It means Euclid is trying to say, through this point, infinite line can pass. Otherwise, why would you need to state this fact that given a line and a point, there is exactly one line that will pass through this point C and parallel to AB? Because if through this point only one line is going to pass, and that is only this line, and it always remain parallel to this. Doesn't make any sense, because this line can be this and this point is here. Then we can always draw this line that is parallel to this line. So does only one line passes through this point, or there can be so many lines passing through this point? If there is so many lines passing through this point, then stating this fact is relevant. Otherwise it is non-relevant, right? Why would we state such a fact if there is only one line passing through this? But we stated this fact because you assume that infinite number of lines is passing through it. What I'm trying to say is, Euclid says, given a line L or AB and a point P, there is exactly one line passing through this point P. Is this true? If I do not add the extra information that Euclid said, which is parallel to this line, if I throw away that part and if I only say, given a line and a point P, there is exactly one line passing through P, that doesn't make any sense. Does it make any sense? No. Now throw away this line and then state a fact. Given a point P, there is exactly one line passing through it. Well, what does it mean? Okay, given a point, there is exactly one line passing through it. So here is one line. Now I can pass another line like this. Why this should be a special and this will be discarded? There is no reason. There is another point I can draw like this. I can pass another point like this. I mean, I can do it in infinite ways. It means, so what does it shows that Euclid postulate, which is postulate number I think 31 or maybe 34, I don't remember this, but that postulate says, given a line and a point P, there is exactly one line passing through this point P such that this and this line will be parallel. So this is our fact 1. But this fact 1, as I said, already contains another fact, and backtrack it, and the fact is, given a point, infinite number of lines can pass through this point. Here is a point. This is another fact. This is another fact. Call it, suppose this fact is zero 3, call it this fact 02. So to state this fact, we need this fact. This fact is built upon this fact. Now we saw that this fact also need another fact to state this fact, because if this through this point infinite number of line can pass, then well, what is the distance between this and this? Let's say here is A, here is B. What is the distance between A and B? We can of course measure it. This is arc length, this is theta, angle. And we can simply use L equal to R theta. L is what? This distance, this arc length. R is what? This radius. This is radius. Because we can draw a circle perfectly like this. I mean, let's make it clearly. What I'm trying to say is, given a point, let's say we draw a line, first line this, second line this. Let's say all have equal length. 4 right now. It is not necessary, but what I want to say is, let's suppose equal length. Then if they have equal length, then we can draw a circle perfectly like this. And if this is a circle, then they all have equal length, they are radius. And if they are radius, then suppose here is angle theta and here is our arc length L. This is, let's say, PQ. This is center, right? And we have this line L1, L2, L3, three lines here. But there can be infinite line, because Euclid says given a point O, here is O, infinite line can pass. But for now we supposed only three lines passing through it. So what we do, if infinite line can pass through this, then what are the presupposition we have assumed to state this fact? Because see, this length is L. Now let's say this L equal to 10 centimeter. So this gap is 10 centimeter, right? This is 10 centimeter. Now, if this is 10 centimeter and the shape is like this, and suppose, so this is 10 centimeter, and suppose it means this much space only we have, 10 centimeter, and we have to fit lines in it. We can fit lines, and all should fit here, all should pass through this point. How many lines we can fit? Well, the questions demand what is the breadth of the line. What is the breadth of line? Before breadth, length does not matter. Length can be anything, because length does not create problem here. The problem is breadth. If a line has if our line has 3 centimeter breadth, then first line will be like this, 3 centimeter. Big line, and it cannot even pass through this point. That doesn't make any sense. And that is not a line. You can see it because it has breadth. So what we need to suppose to state the fact that through this point infinite line can pass. Through this finite space, see, this is finite space, 10 centimeter, but through this finite space infinite line is passing. It means each line must have zero breadth, so that it is not going to occupy the space. So that is the assumptions. Given a point, infinite line can pass. This was our fact 02. But to state fact 02, we need another fact, and the fact is 01. Fact is 01, and this fact says a line is breadthless length. It means a line has only length, it has no breadth, zero breadth. Only if it has zero breadth, then only we can state this fact that through a given line infinite number of lines can pass. Now if it has zero breadth, then yes, this can hold, and it has some length. Now even this fact relies on another fact, because what do you mean there is no breadth, only length? What is length then? What is this line we are talking about? What kind of object this is that has no breadth? What is this made up of? Right? And for that we need another fact 00, which says a length is nothing. A line is nothing but collection of points. I would not even use the word collection. What I am trying to say is a line is made up of points. So many points. This is a line, and this line is so many points here. Infinite point is on this line. And those infinite line, the locus of this point in this straight way, that is what going to make this line. That is line. So this is the fact, another fact, that point all those points if we put together here, this is what going to make this line. So line is what this, so many point makes a line, infinite points making a line. But then what is the point? That is another fact. Fact prime something 0 0. This was fact 0 0. This is fact prime 0 0. A fact prime 0 0 is what? It says what is point. What kind of object is this? Right? Euclid says a point is lengthless, breadthless and heightless. It has no volume, zero volume. Surface area 0. Everything 0. It has no dimension, 0 dimension. Well, but if you have 0 dimension, you have nothing. Right? If something has no length, no breadth, no height, how come it exists? That is the problem. Because if I draw this line, does it not have breadth? Of course it has breadth. It does. We can see here, it does have breadth. So, in the real world, this line does not exist at all. Because in real world, if this has breadth and this has length, and this has length, of course it has, then here is a point. And I can fill this whole copy, this whole notebook with point. So here point does exist here. And it is not a point because it has dimension. We can calculate its surface area. We can do it. So where is point now? Where is point? What is even a point? If it has 0 length, 0 breadth, 0 height, then what is a point? What is that makes it a point? That is the problem here. And it's a philosophical question. So Euclid says a point is that which has no parts. No parts means what? It cannot be divided. You cannot divide it further. A line can be divided. You can divide it in piece. You can make it infinitely thin. You can make it infinitely thin. Any line. Given a line, we can create infinite interval here. Infinite number of interval. But how is this possible? This is only possible because a line can be partitioned. It has parts. But a point has no parts. It has no parts. You cannot break it. It is like Democritus' concept of atom. Atom is something that is indivisible. You cannot break it further. The point is similar to that. Is point a physical object? Well, it cannot be because it does not exist in the world. Because if something exists in the world, it should have matter property. Some mass or weight or energy or momentum, right? It should have some length, breadth, some volume or some pressure, whatever physical quantity we can associate with. If something exists in the real world, this is our real world. This is our space-time. I'm not going to deep into this, but since foundation of mathematics also connected to this idea of philosophy of mathematics, it is very important to discuss these things. And I am not going to go very deep into it, but very little I will give introduction to this idea of abstract object and physical reality in the next lecture. So for now, we'll stop here, I guess.